This engine has been good to me, but it's time to tear further into it and see what's really going on. I did not experience a failure, so I do not expect to find anything, but who knows what's in store. There are many measurements that need to be taken in order to know the condition of our block and the parts we plan to reuse. Many home mechanics trust machine shops to perform this work, but we are all human, and at the end of the day, it's your parts, money, and time that are at risk here. Granted, it's not always feasible to purchase expensive tools to only use them once. During my first build, I found over 1,000ths of taper in my cylinders after the machining work was completed. It was fixed by boring the block over, but this is one example where a few measurements helped this build perform properly for many years. You can imagine how skipping out on these measurements now may lead to some costly mistakes. I was impressed by how clean the valve cover was after this many years. You can choose to remove the cams now if you would like. I just decided to loosen the cam caps, working in sequence from inside out, to release the tension on the cams and ensure the valves were closed. If you leave the cams torqued down and remove the head, you risk possibly bending a valve if the head is placed on the open valves. The head bolts should be loosened from the outside in. The order can be tricky, so just remember, the next bolt you're going to loosen should be the farthest away from the bolt that you've just loosened. I decided to remove the head as an entire unit and tear into it separately to keep things organized. The carbon buildup on my pistons seemed acceptable, but that clean portion of the exhaust valve is on every piston. It may have something to do with the high exhaust back pressure pushing back into the cylinder. That's just a theory though. We did disable the clutch start switch to greatly decrease the load on startup, and I'm sure this aided in minimal thrust wear. The reason this is important is because there is little or no oil to protect the thrust bearing at startup. Another contributing factor is the increased pressure that is applied by aftermarket clutches. According to Road Race Engineering, a stock clutch replacement measured 380 pounds at install height and 420 pounds when engaged. An ACT 2600 measures 530 pounds installed and 710 pounds when engaged. If you compare the engaged pressures of both clutches, the ACT applies 290 pounds more pressure when engaged. Do you see why the clutch start switch could cause an issue here? That's never a good sound to hear inside your oil pan. What we have here is two of the oil jets from the oil squirters. They're pretty beat up. For some reason they made contact with something and broke off. My guess is that it has been running like this for a majority of the build, but it should make for some good comparison between cylinders with and without oil squirters. Before you tear your pistons out of the block like a mad scientist, it's important to note the cylinders they came out of. Also, your rod caps and rods should be kept together with their respective bearings. My rod caps and rods are already stamped as a pair, so if yours are not, do so now to avoid mixing them up. Endplay is a measurement taken at the crankshaft to annotate the amount of axial clearance between the thrust collar and thrust bearing. This clearance is critical in maintaining proper oil film and therefore proper placement of the crankshaft. At this point, this task only requires a few tools. You will need a dial indicator, some type of stand, and a pry bar or flat tip screwdriver. Attach the dial indicator so that it is parallel to the length of the crankshaft. Zero the dial indicator now to avoid any math later. Using the pry bar, apply slight pressure to one side of the crankshaft. Note the reading on the dial indicator. Now apply pressure using the pry bar in the opposite direction and note the reading. Lastly, apply pressure back to the start position to ensure the gauge zeros. The amount of travel between the 2 points will be your end play measurement. I do my best to zero the gauge to make the math easy. The indicator is reading just before 0 and just before 34 10,000ths. So we have 34 10,000ths of play here. You're not done just yet. Rotate the crank 180 degrees and take the measurement again. You should get the same measurement here. If they don't match up, you need to have the crank and main bores checked. It's reading right on 0. I get a few 32 10,000ths readings, and then we get our 34 10,000ths. Factory spec is between 20 10,000ths and 70 10,000ths with a service limit of 98 10,000ths. At 34 10,000ths, we are on the tighter side of spec, and that's after 4 years of running an ACT 2900 pressure plate. Happy boosting!